Okay, so in the last video we looked at trigonometric ratios as distances, and what we concluded was that if you had a unit circle, then your opposite side automatically becomes sine theta, because opposite by hypotenuse, which is 1, is sine theta, and your adjacent side becomes cos theta. Now the question is, how do you extend it to tan theta? How do I get a tan theta? And so tan theta, if you think about, if I can get a ratio of tan theta by 1, then if I can get this as sine theta by cos theta, right, then I can get tan theta as a length. So for that to happen, I can do similar triangles, and in my similar triangle what I need is that my x value, this value has to be 1. So if I draw a straight line, this distance is always equal to 1, and so this equation of course is x equal to 1, the equation of the line as well. So if I just extend this is right angle, the smaller one, the original one is a right angle triangle, the bigger one is also a right angle triangle. So these two triangles are actually similar, these are similar triangles. So if they are similar triangles, I can take the ratio of opposite side by adjacent side, and that will be the same as opposite side here by the adjacent side here. So what I am going to get is that this height is tan theta, because this we have already said is 1, right? So this is 1. So in this way, tan theta is also now a length, and it corresponds to the length of having a line which is x equal to 1, and basically having drawing my line here with the angle theta, right? So this angle is theta, then wherever it intersects is tan theta. Okay, well, that's nice, right? So what does that tell us about tan theta, right? So if I start here, my height is 0, right? So again tan 0 is 0. Reduce this. Okay, when this height is equal to this height, so then this is 1, that is 1, so that's 45 degree at that time. So tan 45 is actually equal to 1, because the height will be 1. That's when you will get an equilateral isosceles triangle with both the sides equal to 1, right? Okay, makes sense. So tan 45 is 1, that's nice. And as we keep increasing tan, yeah, you can see that this shape sort of blows up. So let's see, let's draw that. Okay. So let's say I have a unit circle, I have this line, and I increase the angle. There was one angle I drew there, let me draw a different angle. So I can clearly see that the tan theta is really increasing a lot. And when you say theta is 90 degrees, right, that means these two lines will be parallel, it will never touch. So 89 degrees, it will touch really, really far. So in this you can see that as tan approaches 90 degrees, right, this is starting to approach infinity. It's blowing up. Okay, so that's one thing we can see from this curve, right? The second thing we can see from this curve is, once I move to the next quadrant, right, this quadrant will intersect this line only in the bottom. So my tan is starting to become negative. So this one, tan in the second quadrant is negative, just as tan in the first quadrant was positive. Tan in the first quadrant is positive. Then again, what happens when I reach the third quadrant? So if this, in this my angle was this one, this was theta. Now as I keep increasing my angle, and let's say I have come here, so my angle is this one, this is theta. You can see again that tan 1 and 3 are positive, and as we keep rotating further and the angle goes all the way here, again the fourth quadrant, tan is negative. So these are things we can very easily see about tan from this curve itself. Okay, and what I had missed in the last video is that when you have sine and cos, as Pythagoras theorem will give you cos square theta plus sin square theta as 1, which is also a proof. Okay. So now, what else can we see in this curve? Now, interestingly, the same shape, right? What we find is, what would be the length here? I mean, the 1 is the inside the circle. If I look at this distance, what is that distance? Okay, so let's try to understand that. So I know that this is 1. So same, it's a similar triangle. That's my hypotenuse. So let's say I'll do hypotenuse divided by 1. Hypotenuse, well, I could have put green. Okay, hypotenuse divided by 1 is the same as hypotenuse there, which is 1 divided by cos theta. So this is basically secant theta. Interesting. Okay, I should have written in this color. Okay, so my hypotenuse is secant theta. So that's very interesting. So now when I have a unit circle, what this is telling me is, in my unit circle, I have this x equal to 1, and if I just draw this line, this is tan theta, this is secant theta, and of course this is 1. So again, if I have questions in which I have been given this distance, then I can figure out the other two, as this is secant times that, and we'll scale this triangle, right? That's one thing. Okay, the second thing is, of course, what about secant theta? So we've done so much about tan theta, what about secant theta? What do we know about secant theta? Well, the first thing we know about secant theta is it's always more than 1. Why? It's always outside the unit circle. Here it's 1, and everywhere else it's always going to intersect it only outside the unit circle. So the magnitude of secant theta, right, is greater than or equal to 1. Okay, that's one thing we know. The second thing, we can, again, the positive negative part, right? You can see secant theta is positive here. Once the angle goes there, secant theta becomes negative. Once it goes here, the secant theta, it needs to change direction. So how do you talk about a hypotenuse, right? So the hypotenuse is from the center. If I'm going in the direction that I wanted, then it's positive. From the center, if I go that direction, I'm not going to hit the axis, so I need to turn around. So that becomes negative. From the center, if I go out, I'm not going to hit the line, so I need to turn around, so that becomes negative. And from the center, I can directly go this outside, so this is positive. So the hypotenuse definition of positive negative, it includes both x and y, is it has to do with where I'm going. Yeah? So then that gives me that the secant theta is basically positive in the first and fourth quadrant and negative in the second and third quadrant. So I know all these things about secant theta, and the other very interesting thing that comes out of this right angle triangle is the identity that 1 plus, or 1 square, which is 1, plus tan square theta basically gives me secant square theta. I can see this from the right angle triangle. 1 tan theta secant theta. Secant theta is a hypotenuse.